Hello, welcome back. I'm Henry. Here to talk about some of the code I wrote. Another one of these little Tinker programs that I was just messing around with. The goal of this code was to take an image of emission spectra with the different bands across it, run it through, store it as an image, run it through the code, and be able to say what element it is or what elements are in it. There were some hiccups. There's always hiccups. I feel like there's always hiccups. But the big one was it was really hard to find good emission spectra images, like these bar images. This is the reference image I used. I just Googled emission spectrum and just picked this one. I picked it in part because it's composed of 5 different elements that are then combined into one unknown combination. And because of that, I can sort of practice reading pure elements and reading combined elements. But I wanted to look at this, and I used a program called Photopea, which is just a free program online that I'll have a link in the description if you want to use it, but it's free Photoshop pretty much. What I did is I took each of these bands and made them each 700 pixels long. And that was really important because the code is running for 700 pixels, 700 steps. Then with each of those pixels, I wanted to make sure that they are pure black besides these bands. Like, you see how this green is slightly a different color green than the one next door? That's okay. That's fine. Doesn't matter too much to me. What the issue was if you can see here, that RGB value is not pure 000 when it should be black. And if I move over one more, still not pure black. Another one, now we're at pure black. This one is one of the ones that I haven't edited. But what I did is I edited it and turned all of those into pure black where they should be. So then I was able to look, what the code is looking is for just black things. I don't really care if the band is green or purple or blue or red or whatever or yellow. All I care about is where the black is. And that I'll sort of explain that more soon here. But let's jump right into the code. So what I first have is I want to get into the directory. That's what all this fun stuff is, just getting into the directory where I store all these images. And the next, I'm getting a black image reference frame. What I want to do is I have just a block of black as a picture that I've stored, and I can guarantee any pixel in it will be black, pure black, not some of that very slightly off black, but pure black. I then store that, and then I can reference that later. I can compare the pixels in my unknown to this black to see if they are indeed true black, or if they're not, then I store them, and I'll talk about that soon. Next is I store each of those elements. You remember those bands I was just showing you from that Google image. I stored each of those bands as its own. And what I did, I have this is hydrogen, is helium, is oxygen, is nitrogen, argon, and whatnot. I have each of those go through just the first row of pixels at the top of each of those images and store those values. I store black as 0 and not black, which is any color, as 1. That's important, and I'll get to that soon. But I'm able to have these 5 different elements, so I can check if something either contains these elements, is made up of all these elements, is just this element. But these were the ones that are provided in that Google image, and that's kind of why I picked them. This is totally expandable. I could totally just add everything else, but I didn't have any other reference data was the issue. Next, I just pick an element that I want to look at. Right now, I'm just looking at helium. If I wanted to look at that unknown, I could, but we're going to leave it at helium for now so that I can show you that it's working. This is just in case I ever needed to come back to it. This is the range of wavelengths that I'm looking at specifically. And then I use the same strategy I've used before where I declare an array as empty and then append to it. It's the same strategy I used in my is loops where I just append a 0 or a 1. Now this is taking the data pretty much the same way that I'm doing here for the different elements, but this is doing it to that unknown one. This is the one that could be helium, it could be unknown, it could be argon, it could be whatever. And I'm doing the same process where I'm storing black as 0 and color or not black as 1. Then I go into this comparing file that I've written where I look at all of the different spots in each of them and I add them up. The reason I want to add them up, so I'm going to take the first position of whatever I'm comparing it to and the unknown. I'm going to take them and add them together. Because I have blacks as zeros, those will add to zeros. If they both have color there, then those will add to 2. So anything that is left over as a 1 means they don't disagree, they don't agree there. They are not the same there. So if everything adds up to 2's and 1 or 2's and 0's and there are no 1's, it is exactly that element. It is spot on that element. And that's why I want to do this, so I can compare it to these. Now, what I wanted to check beyond that is if it contains it. So I did a very similar sort of strategy, but where I flipped the value. And now I can know if my element has a 1 in it, where I know there's color, and my compare value has a 2 in it, where I know there's a color, because 1 plus 1 is a 2, 1 meaning there's both colored. If those are both true, then I know for certain that whatever color is in my checking element is in my unknown element. So then if everything lines up perfectly, then I have that element in there. Finally, I just see if they're equal and print that out. So running this, as I said here, I have helium, and if I look down here, I didn't do the print statements very well, but checking is helium, and it is helium. It is true. Now if I go with, let's go argon, why not? Run it, all of these are false except for the last one, and the last one is argon. Perfect, working. And then if I go with the unknown, which we know contains all 5, everything is true. So this was just a fun little project that I tinkered with for a bit, worked on more imaging processing. I want to figure out a way to do the image condensing in Python. I don't want to have to rely on Photopea or any other photo processing for that matter. The next step, I think, is finding a way to condense images in Python on its own. Don't know how to do that? That'll be the next step in the adventure. Again, if you have any comments, concerns, questions, queries, just things you gotta get off your chest, please feel free to leave them in the comments, and I'll see you next time. Bye!